For an assignment, I was tasked with programming a 3D printed hand to perform finger movements. So this video will talk about the construction of the hand and circuit, explanation of the code, and a demonstration of the finger movements. To begin, it was required to 3D print all of the parts. Now, I was given the CAD STL sketches for all the hand parts. However, I did have to perform the 3D printing and construction of the hand myself. Therefore, the first step involved preparing the CAD STL sketches for 3D printing. This was accomplished through the application ZSuit. This application allows a user to adjust 3D print settings such as model size, layer thickness, the type of infill to be used, and how many support structures need to be generated. Additionally, the application allows a user to place the CAD STL sketches on a virtual 3D printer build plate, and adjust the position and angle of the sketches to ensure that no parts would fuse together or be built on top of one another. Once all the 3D print settings were finalized and the sketches were positioned appropriately, the file was exported as a codecs file onto a USB stick. The USB stick was plugged into a Zortex M200 Plus 3D printer and the 3D printing began. Multiple 3D prints had to happen in order to correctly 3D print all parts. All the 3D printed hand parts can be seen on screen. With all the hand parts 3D printed, construction of the hand then began. So this is the final outcome of the hand. As you can see, it's very bendy. So focusing on how we attached a finger to the palm of the hand, we took a fingertip and connected to a finger knuckle via this finger pin, and then we connected this finger knuckle to the palm of the hand via this short knuckle pin. And through these two joints, we got a pretty good range of motion. The finger's pretty bendy, and we did that for all four fingers, including the thumb, but the thumb used the thumb components. So, with the thumb and fingers attached to the palm of the hand, the next step involved running fishing line through the palm of the hand. So fishing line entered through these holes at the bottom of the palm of the hand. That's where the fishing line entered. And then it ran through this section and then emerged from these holes at the top of the palm of the hand. That's where the fishing line emerged from. And the fishing line could then be attached to each finger. It was attached to the bars, the little notch at the top of the fingers. That's where the fishing line was attached to. That's where one end of the fishing line was attached to these bars. Same thing with the thumb. The fishing line emerged from this hole here, went over here, and then attached to this little bar over here. So the other end of then the fishing line was attached to a servo motor. We have five, one for each finger. And the reason for this is because when the servo motor would rotate, that would count as a finger contraction. And then we'll just hold in this position and the finger would remain contracted. And then when the servo motor went back to its neutral position, the finger would also then go back to its neutral position. To assist the servo motor in extending the finger, dental bands were used. So right there, right over here, dental bands were used in these little slits over here. These assisted in returning the finger back to its neutral position and extending the finger. So through the servo motor was able to contract the finger, and then the servo motor returning back to its neutral position, and the dental bands is what assisted in extending the finger. So yes, through the servo motor and dental bands, the fingers were able to be contracted and extended. And that's it. That's how this whole mechanism works. And so the next section will talk about the circuits. So here's the circuit. This will be a very quick run through of the circuit as it's a very simple circuit. And Arduino Uno was the chosen microcontroller of the circuit. This is because it is extremely easy to use and achieves a necessary function in programming the servo motors. The servo motors have a color code system to differentiate inputs. The brown wire is connected to ground, the red wire is connected to the positive terminal, and the orange wire is connected to a respective digital pin of the Arduino Uno. These servo motors were connected in series and received a voltage supply of 8.3 volts. So with the circuit explained, we'll now move into the code. So here's the code. At the start we include the servo library in order to help us communicate with the servo motors. We use this library as it includes the necessary function, the servo function. This servo function is used here to help us define each servo motor. We have 5, and so each servo motor was given a name related to the finger it was connected to. Then, in the setup code, we use the attach function to define where each servo motor is connected to the Arduino Uno. Now, coming into our main loop, this write microseconds function is what allows us to create hand movements. A 0 after this function will rotate the servo motor 180 degrees, thereby contracting a finger. Whereas, a 3000 after this function will rotate the servo motor all the way back to its original position, thereby extending a finger. Furthermore, the delay functions were also utilized in order to hold positions of the hand and delay movements between the fingers. So now I will explain our hand movements. At the beginning, we do a scissors movement, where the pinky, ring finger and thumb contract, and then we extend them into a neutral paper position. Next, we do a reverse scissors movement, where the thumb, middle finger and index finger contract, and then we extend them back into the neutral paper position again. Moving on, we do a finger gun movement where the pinky and ring finger contract, and then we extend them back into the neutral paper position again. Following that, we do a reverse finger gun movement where the middle and index fingers contract, and then we extend them back into the neutral paper position once more. Finally, we contract the thumb, and then we extend the thumb, after which the code repeats the entire process again. So, with the code explained, we will now move into the demonstration of the finger movements. Alright, so we finally reached the demonstration of the moving hand. But before we begin, it should be noted that the servo motors and the palm of the hand had to be clamped down. This is because this increased the stability of the components as well as assisted in making the fishing line tense, which made it easier for the servo motors to actually rotate and contract the finger. Additionally, I did 3D print an additional part. This part was a wrist. It provided no benefit to the actual function of the hand. It was only created to help the aesthetics of the design and give it a more hand/arm look. Near the beginning of this video, when I was showing the 3D printing, it was this wrist component that was being 3D printed. So, starting the demonstration, the first movement the hand did was the scissors movement, where the pinky, ring and thumb contracted. It then did the paper movement before doing the reverse scissors movement, after which it did the paper movement again before quickly doing the finger gun movements, going back to the paper movement, and then doing the reverse finger gun movements. Then paper, thumb contraction, thumb extension, and we'll repeat the whole process. So that's it. That outlines everything that I did in order to program a 3D printed hand to perform finger movements. This brings an end to this video. Thank you for watching, and goodbye.